Okay, so we're in the bigger box, but kind of technically a smaller footprint. So this camera is going to come out, setting up a testing rig camera. Okay, and then we're using, I have this high-end ultrasonic sensor. It's from something else. We're going to screw with the voltage and the frequency, and we're going to tighten this. It's basically, imagine like an oval. Okay, so like at the normal voltage we're like this, and then we got a certain amount of range. We're gonna pin this thing out like this, with the right voltage and the right, we have to screw with a couple things to make it work, but it'll work in conjunction with the camera and the this just makeshift mount and stuff like that. And then we have, so we have a separate little area for the power system here. So with the switch on it, and then with all the connections in there, and stuff that could, I wasn't happy with where things were. The GPS connection comes down, folds right in here like this. So and then this is forward here, and we're gonna put some of the starting for the redundancy system. So this RF nano. So these will have radio. The redundancy systems will also have capability to reach out on emergency frequencies and stuff like that as well. If they don't get a response, though, they'll have integral, programming or whatever like that. So basically microcontrollers as well. If no response, we didn't get approval, but we're still falling out of the fucking sky. Okay, now the canister pops and the parachute comes out, or the gas system fires up and the emergency power supply gyrocopter, whatever it is. So we'll be working with these kind of devices. So they'll have radio capability, maybe their own little antenna, and they'll seek permission. But then in all else fails, they go into action, and then they also function as another emergency signaling device for where the thing's going down at, and it'll have some of its own sensors and stuff like that. And battery powered, so like almost like a black box, best way to describe it. So as soon as this stuff becomes activated, we have a homing, a kind of protected, away independent, way to home in on it on the wreckage, or follow its pattern down, or whatever, or if it's sick in flight, to be able to scoop it up wherever it's going to emergency land at. So we're working from there. So the GPS is mounted, everything's mounted. We're going to start. We have the programming, we have everything. What we're going to start doing is running the flight controller. We'll program from the Jetson Nano with the screen and the keyboard. We'll program the flight controller for a specific flight path, and then we'll add we'll start adding those features we're looking for. Expanded navigation functions, meteorology, everything like that. But the main thing here is being able to get this up in the air reliably, and everything powered for a specific amount of time, so we have a specific flight time expectation, and then move from there. So we're moving right along. I think I'm going to stay in this component housing for now, and then we were going to once we're ready, we will be sizing things down to fit within that exact footprint. There's a possibility of stacking stuff, but I need to do a thermal analysis and understand a little bit more of the hot spots within the processing. So where we're going to heat up in specific types of processing, so we can understand the frequency and the amount of time we're going to be on, where the heat sink is going to be firing up. We're going to have the cooling on and everything like that. But where we're going to be at within the processing when we're doing that, how often that's going to be, and ways to minimize that and everything like that. And then from there also where we are hotspot wise thermally, physically on location. So two separate analysis here. We're going to put pressure on this thing, heat it up. We're going to look at how much it heats up, and then we're going to also look at within the placement, what would be responsible. Because to achieve that footprint, we're going to need to stack stuff within a specific cross section. So if we're thinking like this and like this, like this and like this, or whatever like that, we're necessarily going to have components stacked up on top of each other, whether that's battery housings with charge controllers, and then the boards, and then heating components, cooling components, whatever like that, or thermal management components, and then also the flight controller, and then whatever housing and however we decided to do power distribution and stuff like that further back. So we're moving right along. So this is the last time. This is the last time we're going to change the component housing, and we're going to get everything in here and then move from there.